I am Dr. R. Srinivasan from Chemistry Department, IARE. Today we will see water technology topic, water technology module. In that, boiler troubles and softening of water is the topic. Boiler trouble can also be can say as disadvantages of using hot water in boilers. Okay. Disadvantages of using hot water for domestic and industrial purposes. There are a lot of disadvantages in using hot water for domestic and industrial purpose. Washing, for example, we know very well that washing means hot water doesn't produce lather, rather it produces scum. Okay, so cleaning action of soap is disturbed. Okay, cooking, again, boiling point of water is increased because of the presence of dissolved salts. Hence, more fuel and time is required for cooking. Next, drinking water. When it comes to drinking, some of the dissolved salts in water can act as a mineral to our humans to some extent, okay, to very low ppm. But beyond certain level, when hotness of water increases, then it creates problem in our bad effects in our digestive system, and also the possibility of forming calcium oxalate crystals in urinary tracts is increased because of hotness of water. Okay. Textile industry, again we know that water causes wastage of soap due to the formation of hot water, due to the formation of precipitates or scum, and that will adhere to the fabrics and cause problem. Okay, sugar industry. Water containing sulfates, nitrates, alkali carbonates, etc. If used in sugar refining, it causes difficulty in crystallization of sugar. Dyeing industry. So dissolved salts in hot water may react with costly dyes, forming precipitates. Okay, dyes, it forms precipitates. Paper industry. Calcium, magnesium, iron salts in water may affect the quality of paper. So everywhere, the water quality is important. Hardness of water creates problem in more ways. Next, in pharmaceutical industry also, hot water may cause undesirable products while the preparation of pharmaceutical products. In pharmacy, there are the impurities are very important. So impurities should be very less or zero. So in those circumstances, hot water may cause a lot of undesirable products in the preparation of API, active pharmaceutical ingredients, etc. Concrete making. Water containing chlorides and sulfates, if used for concrete making, it affects the hydration of cement and final strength of the hardened concrete, okay, due to the presence of chlorides and sulfate salts. Laundry, it's very well known, much soap because of scum formation, and also iron salts may cause coloration of the clothes. Okay, so we have seen all these things as a hot water, problems of using hot water in domestic and industrial applications. Now, one important, very important application of water is in steam production for the generation of electricity. See, actually, water to steam and steam will mechanical work, which is converted to electrical energy. Okay. Rotation of turbine, and then it converts to electrical energy. Okay. So very important application of water is in steam production for the generation of electricity. So for this, water need to be feed into the system, into the industrial boilers. Okay. For which we need a soft water. We need a water which doesn't have hardness producing salts. Okay. So hard water, if you use directly, it creates a lot of problems in boilers. What is a boiler? Boiler is a vessel which is used to make steam from water. Okay. So for this purpose, hard water, if you use for the steam generation, in order to get electricity from the steam generation, if you use hard water, it will have a lot of boiler problems will be there. Okay, boiler feed water, water for steam generation. A boiler is a closed vessel in which water under pressure is transformed to steam by the application of heat. So, boiler feed water should have the following essential requirements. Okay. Boiler feed water should be free from hardness causing and scale forming constituents. Hardness causing and scale forming constituents like salts of calcium and magnesium. This is because scale formation would result in wastage of fuel, lowering of boiler safety, decrease in efficiency, and danger of boiler explosion, etc. Okay, so we should avoid this hardness causing and scale forming constituents like salts of calcium and magnesium, because it creates the scale formation would result in wastage of fuel, lowering of boiler safety, decrease in efficiency, and danger of boiler explosion. Caustic alkali, okay, we say NaOH, to be avoided because of it will create caustic embrittlement. So what happened? The boilers are made up of iron. Okay, so iron reacts with NaOH to form sodium ferrovate, and this creates lot of makes the boiler brittle. Okay. Dissolved oxygens like oxygen and carbon dioxide, in order to should not be there in water used as boiler feed water to prevent boiler corrosion. Okay, boiler corrosion. Turbidity, oil, etc. to reduce the tendency of priming and foaming. We say carryover. Okay, priming or carryover. There will be a lot of foam formation, which is very difficult to know the water level. Okay. Hence, the water should be softened before the use in boilers. Okay. Okay, in boiler problems, particularly we will see more about sludge and scale formation in boilers. Okay. In a boiler, we know in a boiler is a vessel which is used to convert water into steam by the application of heat. So in boiler, water is continuously evaporated due to heat and forms steam. This increases the concentration of dissolved salts. Okay. So boiler problem means if we use Okay, problems due to usage of hot water in boilers. Under that's what we call it as boiler problems. In that, scale and sludge formation is very important, and it's a major reason we have to see a little bit more. So in a boiler, the water is continuously evaporated and converted to steam. This increases the concentration of dissolved salts. Okay. So after some time, after a stage is reached when the ionic product of this salts exceeds the solubility product, and hence the salts are thrown out as precipitates in the boiler. Okay. Okay, if the precipitates formed are soft, loose and slimy, these are known as sludges. If the precipitate formed are hard, strongly adhered on the inner walls of the boiler, it is called scales. For example, if you see the top view of the tank, for example, so these are example of sludges. Sludges are nothing but precipitate formed as soft, loose and slimy. They can be removed easily. Okay. Another type of precipitate formation in the boiler. It's like the inner walls are strongly adhered by the precipitate. They form a strong layer, hard layer, which is very difficult to remove. We call them as scales. Okay. Okay. This is the formation of scale. Scales are very difficult to remove once it is formed. Even if you hit with a hammer and chisel, it will not come. Okay, so it will be that much harder. Okay. Sludges, basically this type of sludges, which is easy to remove, are formed by magnesium carbonate, magnesium chloride, calcium chloride, magnesium sulfates form sludges. They have greater solubilities in hot water than in cold water. Okay. Okay. They can be easily removed by wire brush, and they can be prevented and removed also by softening the water best way, or by frequently blow down operation. That means when the water level is below certain level in the boiler, that means it contains lot of concentrated salts. You better throw that and then again take the fresh I mean is another water, filled with another water, and start getting the steam. That is called blow down operation. Or you can have a pipe in the lower portion of the boiler. So when water reaches that level, you better remove those water. Okay, and then again start with the another set of filling by filling the water. That is blow down operation. Okay, so sludges can be removed by this blow down operation, whereas scales cannot be removed. Scales: calcium sulfate, magnesium hydroxide, calcium carbonate, calcium silicate. By far, calcium sulfate is the most difficult. Scales are difficult to remove, but calcium sulfate is more notorious because its solubility decreases with increasing temperature. Normally, the salts have solubility increases with the increase in temperature compared to cold conditions. Whereas calcium sulfate, if you increase the temperature also, their solubility will decrease. So they are not soluble because it decreases. Okay? It's difficult to remove even after with the help of hammer and chisel, and are the main sources of boiler trouble. That's why we are seeing this. They are the main sources of boiler troubles. Okay. Okay. Next, scale formation in boilers. How the scales are formed. So we have seen what are the examples of scales, compounds, like salts, calcium sulfate, magnesium hydroxide, calcium carbonate, calcium silicate, like that. Now, scale formation in boilers. Scales may be formed inside the boiler like this due to decomposition of bicarbonate salts, that is called calcium carbonate scales. They are soft and is the main cause of scale formation in low pressure boilers. Okay. In high pressure boilers, calcium carbonate is soluble due to the formation of calcium hydroxide. So they doesn't form a they form a scale, calcium carbonate scale in low pressure boilers, not in high pressure boilers, because it is reacting into in high pressure, it becomes soluble calcium hydroxide. Okay. So we know that already we have seen calcium bicarbonate. Calcium bicarbonate on heating gives calcium carbonate precipitate plus CO2 plus H2O. Okay. Okay. Similarly, okay, calcium carbonate in high pressure it turns to calcium hydroxide, which is soluble in high pressure boilers. Okay. So that's why calcium carbonate scale forms in low pressure boilers. Okay. Right. Deposition of calcium sulfate. This is important. Calcium sulfate is a mineral called gypsum. Gypsum. Calcium sulfate is nothing but gypsum. This type of scales causes trouble in high pressure boilers again. Calcium sulfate scale is quite adherent and difficult to remove. Their solubility decreases with the increase in temperature, as I mentioned. Okay. So, deposition of calcium sulfate is very, very difficult to remove, and it is a major trouble in high pressure boilers. Okay. Hydrolysis of magnesium salts. Dissolved magnesium salts get hydrolyzed, forming magnesium hydroxide precipitate, which forms a soft type of scale. For example, magnesium bicarbonate, when you get heated, it converts to magnesium hydroxide plus 2 CO2. Okay. So this magnesium hydroxide precipitates creates a soft type of scale. Okay. This is by heating bicarbonate. Some salts on hydrolysis also gives magnesium hydroxide. That's just to show the reaction by magnesium bicarbonate also it is coming. I have shown here. But there are some other salts, like for example, magnesium chloride plus hydrolysis 2H2O gives MgOH twice plus 2 HCl. This is another way of another reaction to show that magnesium hydroxide is forming by hydrolysis. It's a soft type of scale. Okay. Presence of silica. Again, even a small quantity of silica is present, it may deposit as calcium silicate and or magnesium silicate. It very firmly deposits on the interior side of the boiler surface and strongly adherent scales. Very difficult to remove again. Okay. Calcium silicate. Presence of silica will create scales, calcium silicate scales. Okay. Okay. Harmful effects of scale formation in boilers. We have seen that wastage of fuel, lowering of boiler safety, decrease in efficiency of the boiler, danger of boiler explosion. Okay. Wastage of fuel due to poor thermal conductivity of scales, because when scales are strongly adhered on the walls of the boiler, the heat will not be spread, or it will not be felt by the boiler equally in all places. In some places it may be more, some places it may be less. So that is very dangerous, and also the wastage of fuel is more. Poor thermal conductivity of scales, and the wastage depends on the thickness. If thickness of the scale is more, wastage is more. And the nature of scales, whether it is a soft or whether it is a hard type of scales, all those things. Okay. Lowering of boiler safety. What happens? The scales formed in boiler, it causes a type of distortion in boiler and makes it unsafe to bear the steam, the pressure of the steam, especially in high pressure boilers. So that is, it may explode also. So it is not a safety one for the boiler. Decrease in efficiency. Deposition of scales in valves and condensers of the boiler chokes them partially. It blocks the surface of passage. Danger of explosion. Sudden development of high pressure in the overheated portions with large amount of steam formation creates explosion. So these are all the harmful effects of particularly scale formation in boilers. Okay. Okay. How will you prevent? Prevention of scales. It is done by various external and internal methods. Okay. Okay. Softening of water. The process whereby we remove the hardness or reduce the hardness of water, irrespective of whether it is temporary or permanent, is termed as water softening. Or you can also say water treatment. Water treatment. Okay. So softening of water can be done by water treatment, can be internal treatment, external treatment. Okay. There are two different types of treatments. Now, water softening by internal treatment methods. Internal treatment means treating the water inside the boiler. So in this process, it's also called sequestration. An ion is prohibited to exist, prohibited to exhibit its original character by complexing or by converting it to another soluble salt by adding appropriate reagent. It is done not outside the boiler, inside the boiler. It is essentially a corrective method to remove those salts which are not completely removed by the external treatment of water softening. Okay. So it's rather a corrective method rather than a preventive method. Okay. So we will see what are the different types of treatment available in this internal treatment of water. In this method, the raw water is treated inside the boiler. Okay. Internal treatment means addition of suitable chemicals to reduce scale and sludge formation and to convert scale forming chemicals into sludge, which can be removed by blow down process. Some of the internal treatment methods used for the removal of scale formation in boilers are phosphate conditioning, carbonate conditioning, calgon conditioning. So these three, we will see this conditioning, different types of conditioning used in internal treatment of water. Phosphate conditioning. It is generally applicable to high pressure boilers. Scale formation is avoided by adding sodium phosphate, which reacts with calcium and magnesium salts to form soft adherent compounds that can be easily removed by blowdown operation. That is, soft means sludges. Okay, not scales, sludges. Here, instead of sodium phosphate, we can also use other sodium phosphate. Okay, reaction examples are given where M is calcium chloride, calcium sulfate. It becomes calcium phosphate plus 6NaCl, calcium phosphate plus sodium sulfate. The choice of phosphate salt depends on the nature of water. For example, sodium phosphate is used when water is alkaline. Na2HBO, sodium hydrogen phosphate is used in the presence of highly alkaline water. Sodium dihydrogen phosphate is used in acidic water. So depends on the nature of water, acidic or strongly alkaline or alkaline, we can use this type of reagents. Okay. Next, carbonate. In low pressure boilers, carbonate conditioning is used. Scale formation can be avoided by adding sodium carbonate, washing soda. Washing soda is nothing but sodium carbonate. So when salts like calcium sulfate can be converted into calcium carbonate. Calcium carbonate can be removed by a blowdown process. It's basically sludges. Converting to sludges. Converting scales to sludges. The sodium carbonate, calcium carbonate plus Na2SO4. Next, important one is calgon conditioning. What is calgon? Sodium hexametaphosphate is called calgon. So, in order to prevent the scale and sludge formation, if you add calgon, sodium hexametaphosphate, it forms a soluble complex compound with calcium sulfate, magnesium sulfate, converts the scale forming impurity into soluble complex compound. Okay. For example, 2 calcium sulfate, this is calgon. Na2, Na4P6O8, it forms soluble complex by substituting here. Okay. So it takes the calcium here and sodium sulfate comes out. So this is a soluble complex. Okay. So thereby it avoids the scale formation due to calcium sulfate. And when it is soluble, then we can remove it by blowdown process, or it is not that much problematic like scales. Okay. Okay, with this video is over. We will continue in the next video.
Like, share and subscribe. Hit the bell icon for more updates.